The morning frost clung to the armor plating as Oberst Heinrich Müller watched the American Tank Destroyer roll into the testing yard at Kummersdorf. December 7th, 1944. The machine looked almost crude compared to the sleek, angular Panthers parked in the adjacent hangar. Its welded hull seemed utilitarian, almost hurried in construction. Müller had commanded panzer units in France and had seen the evolution of German armor from the early Mark IIIs to the magnificent Tiger. This captured American M10, fresh from the Ardennes forests where Wehrmacht forces had overrun a retreating American column, seemed almost insulting in its simplicity. But that morning, as his engineering team prepared their instruments and testing protocols, Müller didn't yet understand what this unremarkable machine would reveal. He didn't know that within 72 hours he would be drafting a report that would sit, unread and ignored, in the files of Albert Speer's Armaments Ministry. A report that quantified, in stark numbers, exactly why Germany was losing the industrial war. The metallic clang of tools echoed across the frozen ground. Somewhere in the distance, the rumble of Soviet artillery had become constant background noise, a reminder that the Eastern Front was collapsing, that the Oder River, Germany's last major barrier, was barely 80 kilometers away. But here, in this testing facility south of Berlin, German engineers still clung to the rituals of technical superiority, still believed that superior engineering could overcome material disadvantage. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. They called it the M10 Wolverine, though American crews simply knew it as the TD Tank Destroyer. The Germans had a different designation, Panzerjäger M10, serial number 4825739, according to the data plate still riveted to its hull. It had been built by the Ford Motor Company at their Highland Park facility in Michigan, rolled off the assembly line in August of 1943, shipped to Britain, and eventually assigned to the 705th Tank Destroyer Battalion. Its crew had abandoned it near St. Vith on December 17th, when a Panther from the Führer-Begleit Brigade disabled its right track with a glancing shot. The German recovery team had it operational again within 6 hours. That fact alone should have told Müller something. The M10's profile was distinctive, an open-topped turret that seemed almost reckless in its exposure, a 3-inch main gun that was adequate but not exceptional, armor that peaked at just 2 inches on the frontal arc. To German eyes, trained on the doctrine of heavily armored, powerfully gunned vehicles, it looked incomplete, like someone had stopped building it halfway through. Hauptmann Werner Schulze, the facility's lead automotive engineer, had spent the 12T's previous evening examining the vehicle's drivetrain. Schulze was 41, had designed suspension systems for Daimler-Benz before the war, and had personally overseen trials on every major German armoured vehicle since 1941. He approached the M10 with the same methodical precision he'd applied to the Tiger, the Panther, the Jagdpanther, remove the access panels, photograph everything, measure tolerances, document assembly methods. What he found disturbed him, though not for the reasons he expected. The M10's engine was a pair of General Motors diesel engines, twin 671s, mounted in tandem. Each engine displaced 425 cubic inches, generating 110 horsepower. Together, they produced less power than a single Maybach HL 230 that drove the Panther. The transmission was a simple synchromesh affair, nothing like the sophisticated double differential steering system in German heavy tanks. The suspension used vertical volute, springs, a design the Germans had abandoned in the 1930s as too crude. And yet, the build quality is extraordinary, Schulze wrote in his preliminary notes. Not in the sense of precision, but in reproducibility. Every weld is identical, every fastener is standardized, the entire engine package can be removed and replaced in under 4 hours using basic tools. By contrast, engine replacement in a Panther requires specialized equipment and takes, minimum, 16 hours under field conditions. This was the first crack in the edifice. The broader context of late 1944 made these observations particularly bitter. Germany was producing, at maximum capacity, approximately 350 Panthers per month. The Americans were building 850 M10 tank destroyers monthly, alongside thousands of Sherman tanks, hundreds of heavy bombers, and seemingly endless supplies of trucks, half-tracks, and support vehicles. The numerical disparity had become grotesque. But German doctrine had always held that quality trumped quantity. One Tiger could engage and destroy multiple Shermans. One Panther, with its sloped armor and long 75mm gun, could dominate any American tank at range. The mathematics of superior engineering would eventually overcome numerical disadvantage. Except the mathematics weren't working out that way anymore. Müller had commanded a Panther battalion in Normandy. He'd seen firsthand how Allied air power negated German armor's tactical advantages. He'd watched Panther's magnificent machines immobilized by minor mechanical failures, while American vehicles kept rolling, despite damage that should have been catastrophic. He'd seen German recovery teams spend days retrieving and repairing a single disabled Tiger, while Americans simply abandoned damaged vehicles and brought forward fresh ones from seemingly infinite reserves. The industrial reality of the war had become undeniable. But German military culture resisted acknowledging it. The belief in technological superiority ran too deep and was too fundamental to German national identity in this war. The Wunderwaffen, the miracle weapons, would turn the tide. The Me-262 jet fighter, the Type XXI U-boat, the King Tiger tank. Superior German engineering would prevail. The M10 sitting in the Kummersdorf testing yard represented a different philosophy entirely, one that German engineers had been conditioned to view with contempt. It wasn't that the Americans couldn't build sophisticated vehicles. The P-51 Mustang proved they understood aerodynamic refinement, but the M10 embodied a deliberate choice. Build something good enough, build it quickly, build it in numbers that made individual losses irrelevant. The testing protocol was extensive. Müller wanted automotive performance data, armor resistance values, gun accuracy statistics, crew ergonomics assessments. But he also wanted something else, something that wasn't standard procedure, a complete cost analysis. He wanted to know, in exact figures, what it cost to build this American machine. Getting those figures wouldn't be simple. The German military didn't advertise the cost of their vehicles. Such information was classified, but Müller had contacts in the armaments ministry. He'd seen the internal reports. He knew, approximately, what a Panther cost to produce. He suspected the Americans would be more forthcoming with their data, perhaps even recklessly transparent in the way democracies often were with information that should be secret. He was right. The interrogation of captured American maintenance personnel from the 705th Tank Destroyer Battalion provided unexpected specificity. Technical Sergeant Robert Morrison, captured near Schönberg, had been a factory representative from Ford before being drafted. He knew production figures, he knew the costs, and he talked freely, partly because he didn't consider such information particularly sensitive, partly because he was exhausted, cold, and scared. $50,000, Morrison told his interrogator on December 19th. Give or take. That's the unit cost for an M10. The engines are about $3,000 each. Transmission maybe $1,500. The gun another $4,000. Hull and turret fabrication, assembly labor, all the small parts, it adds up to around 50 grand. The interrogator, Lieutenant Franz Dietrich, who'd studied economics at Heidelberg before the war, understood immediately why this mattered. He'd seen the classified reports. He knew a Panther cost approximately 320,000 Reichsmarks to produce roughly $128,000 at the official exchange rate, but closer to $300,000 when accounting for Germany's resource scarcity and manufacturing inefficiencies, 6 times more expensive. And the Panther wasn't even Germany's most expensive tank. When Dietrich brought this information to Müller, the Oberst's reaction was silent calculation. He stood at the window of his office, watching snow begin to fall across the testing yard, and did the arithmetic that condemned his nation's war effort. Germany produced 350 Panthers monthly. At $300,000 equivalent cost per vehicle, that was $105 million of productive capacity. The Americans produced 850 M10s monthly, more than double the quantity, at $42.5 million total cost. They were generating more combat power for less than half the investment, and that didn't account for their simultaneous production of Sherman tanks, Stuart light tanks, and dozens of other vehicle types. The material equation was impossible. Germany couldn't win an industrial war, it was already losing by a factor of 6 to 1. But Müller was a professional officer, trained to assess threats and capabilities, objectively. Personal feelings, despair, anger, resignation were irrelevant. His job was to understand this American vehicle completely, to extract every lesson it could teach, and to report those findings accurately. Whether anyone would listen was beyond his control. The M10's design philosophy became clearer as testing progressed. It wasn't built to be the best tank destroyer. It was built to be good enough, quickly produced, easily maintained, and fielded in overwhelming numbers. Every design choice reflected this priority. The open-topped turret, which seemed like a vulnerability, actually reduced weight and manufacturing complexity. It allowed for better crew ventilation and easier ammunition handling. German tank destroyers like the German Panther had fully enclosed superstructures, which provided better protection but required more complex manufacturing and added weight that stressed the drivetrain. The M10's 3-inch gun could penetrate 4 inches of armor at 500 yards, adequate against most German medium tanks at typical engagement ranges. It wasn't the equal of the Panther's long 75mm gun, but it didn't need to be. American doctrine emphasized combined arms coordination. The M10s would engage enemy armor with air support, artillery support, and infantry support. German doctrine increasingly relied on individual vehicles operating in isolated superior positions, because that was the only way to maximize the effectiveness of their limited numbers. The twin diesel engines represented another fundamental difference. Gasoline engines provided more power per unit weight, which German engineers preferred. But diesel was safer, less likely to ignite when hit, and more fuel efficient. The M10 could travel 200 miles on a single tank load. Panthers managed about 120 miles under ideal conditions, often much less in combat. German logistics struggled to keep vehicles fueled. American vehicles arrived with fuel to spare. Even the suspension revealed different priorities. German engineers had developed sophisticated torsion bar systems that provided excellent cross-country performance. The M10's vertical volute springs were cruder but required no specialized tools to repair. A field mechanic with a wrench could replace a broken spring. Replacing damaged torsion bars on a Panther required returning the vehicle to a depot facility. Schulz's engineering report, completed on December 21st, was brutally honest. He listed the M10's deficiencies: inadequate armor protection, mediocre crew protection, insufficient gun power for long-range engagements. But he also documented its advantages: mechanical reliability, ease of maintenance, standardized components, rapid production capability. His conclusion was devastating in its implications. The M10 represents an optimized solution to mechanized warfare under conditions of industrial mass production. It sacrifices individual vehicle superiority in favor of operational quantity and sustainability. Against this production philosophy, quality-focused manufacturing cannot prevail unless the quality advantage is overwhelming. Current German armor enjoys perhaps a 30 to 40% combat effectiveness advantage per vehicle. The Americans deploy vehicles at 300% numerical superiority. The arithmetic is unsustainable. Müller read the report twice. He understood what Schulze was really saying. Germany was building tigers when it needed to build wolves, not because wolves were better hunters, but because you could field 10 wolves for every tiger, and quantity had its own quality. The cost analysis landed like an artillery shell. Müller received the complete cost breakdown on December 23rd. The numbers were worse than he'd imagined, not just for the vehicles themselves, but for the entire production ecosystem they represented. The M10's hull was constructed from rolled homogeneous armor, plate, welded together using semi-automated processes developed by American shipyards. Ford's Highland Park facility could fabricate a complete M10 hull in 37 hours of labor. By contrast, a Panther's interlocking, sloped armor plates required 120 hours of skilled labor to assemble. The difference wasn't German inefficiency. German welders and fitters were among the most skilled in the world, but rather the inherent complexity of the Panther's sophisticated design. The Maybach HL 230 engine that powered the Panther was a masterpiece of engineering. A 23-litre V12 producing 700 horsepower, it represented the pinnacle of German automotive technology. It was also a nightmare to manufacture. Each engine required approximately 550 hours of machining time, used specialized alloys that were increasingly scarce, and demanded tolerances measured in hundredths of a millimeter. The M10's twin General Motors diesels were, by comparison, almost agricultural in their simplicity. They were derived from commercial truck engines. GM could produce them in its Detroit facilities at a rate of 1,200 units per day, using standardized machine tools and semi-skilled labor. Total manufacturing time, per engine, 18 hours. Schulze had calculated the labor differential. Germany devoted approximately 55,000 man-hours to produce a single Panther, from raw materials to completed vehicles. The Americans spent 9,000 man-hours building an M10. Even accounting for differences in worker productivity, German propaganda claimed German workers were more efficient. Though Schulze privately doubted this, the Americans were generating combat vehicles at 5 to 6 times the efficiency ratio. The implications extended beyond tanks. Every hour of German skilled labor devoted to hand-fitting a Panther's transmission was an hour not spent building trucks, artillery pieces, or fighter aircraft. The Germans were optimizing for individual unit excellence, while the Americans optimized for systemic throughput. In a short war, Germany's approach might have worked. Superior vehicles, superior tactics, superior operational art could achieve decisive victories before numerical advantages materialized. But by late 1944, the war had ground into an attritional struggle, and attrition favored the side that could replace losses fastest. Müller had the evidence now. He understood the material reality. But understanding didn't suggest any solution. Germany couldn't suddenly retool its entire industrial base to build simpler, cheaper vehicles. The infrastructure didn't exist. The machine tools were specialized for current production. The supply chains were optimized for existing designs. And even if Germany could replicate American production methods, it lacked America's resource base: unlimited petroleum, abundant iron ore, vast electrical generating capacity. The testing continued through Christmas. German engineers subjected the M10 to trials that would have been impossible on the shrinking Reich's actual battlefields. They fired the 3-inch gun through 500 rounds to test barrel wear. They drove the vehicle across the facility's obstacle course repeatedly to stress the suspension. They measured armor resistance by firing captured American and German weapons at the hull from various angles and ranges. The results confirmed what Schulze had suspected. The M10 wasn't exceptional in any single metric. Its armor couldn't match a Panther's. Its gun was adequate but not outstanding. Its cross-country speed was respectable but not remarkable. But it didn't fail either. The drivetrain proved remarkably robust. The suspension handled punishment that would have damaged more sophisticated systems. The gun maintained accuracy even after heavy use. It was, in every sense, good enough. On December 27th, Müller conducted a live-fire comparison. The testing yard had a captured Panther, available one of dozens that had broken down during Germany's own retreat and been recovered by German maintenance units. It was fitting, in a dark way, that German engineers would compare a captured American vehicle against a recovered German one. Both were casualties of mechanical failure rather than enemy action, a detail that spoke volumes about the Wehrmacht's logistical crisis. The Panther's long 75mm gun was superior to the M10's 3-inch weapon in every measurable way. It had higher muzzle velocity, better penetration at range, more accurate fire control optics. At 1,000 meters, The Panther could reliably penetrate any American tank's frontal armor. The M10 would struggle to engage effectively at that range, but the comparison was misleading. In actual combat conditions in France and Belgium, engagement ranges had averaged 300 to 400 meters, close terrain, hedgerows, village, streets, winter forests. At those ranges, the M10's gun was perfectly adequate, and while the Panther might win a theoretical duel, American doctrine didn't believe in fair fights. M10s operated with air support, artillery support, infantry support, and most crucially, with other M10s, American units expected to lose vehicles. They built their tactics around that assumption. German tactics assumed vehicles were precious assets to be preserved. Losing a Panther meant losing 6 months of skilled labor, scarce materials, and irreplaceable manufacturing capacity. Commanders became cautious, defensive, reluctant to risk valuable machines. American commanders could be aggressive, could accept losses, because replacement vehicles were already in the supply pipeline. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The psychological dimension fascinated Mueller more than the technical specifications. He'd interviewed several captured American tank destroyer crewmen during his time at Kummersdorf, trying to understand their mindset. What he found surprised him. American crews didn't particularly love their M10s. They complained about the open turret, joked about the vehicle's thin armor, called it a tin can or purple heart box. They weren't laboring under illusions about technical superiority, but they had absolute confidence in American industrial capacity. They knew that if their vehicle was destroyed, another would be available. They knew spare parts existed in abundance. They knew mechanics had the tools and materials to keep vehicles running. German crews, by contrast, treated their vehicles like irreplaceable heirlooms. Panther crews would spend hours performing maintenance that American crews would delegate to supply units. They nursed vehicles through mechanical problems that Americans would have resolved by swapping out entire assemblies. Not because German crews were more dedicated, but because they knew replacement parts might not arrive, that recovering a disabled vehicle might be impossible, that losing a tank meant their unit lost combat power it couldn't readily replace. This psychological burden, the knowledge that every vehicle was precious, that losses were potentially permanent, affected tactical decisions at every level. German commanders husbanded their armor, deployed it cautiously, pulled back rather than risk destruction. American commanders expended their armor, used it aggressively, and accepted losses as the price of operational momentum. The statistics told the story. Germany produced approximately 19,000 Panther tanks throughout the entire war. The Americans built nearly 49,000 M10 tank destroyers, plus 65,000 Sherman tanks, plus thousands of other armored vehicles. Even accounting for Germany's production of other tank types, Tigers, Panzer IVs, assault guns, the numerical disparity was crushing, and the Americans weren't just outproducing Germany. They were outproducing Germany while simultaneously supplying the Soviet Union, equipping British forces, and maintaining vast naval and air forces across 2 oceans. The Lend-Lease program alone had delivered over 14,000 American aircraft and 7,000 tanks to the Soviet Union by late 1944. America was fighting a multi-front war while treating equipment as expendable. Muller's final report, submitted to the Armaments Ministry on January 2, 1945, ran to 47 pages. It contained detailed technical specifications, comparative performance data, and cost analyses. But the conclusion was simple enough to summarize in a single sentence. Germany cannot win a material war against the current Allied coalition. The report generated no response. It sat in the ministry files, likely unread by anyone with decision-making authority. By January 1945, such analyses were irrelevant. The Eastern Front had collapsed. The Western Allies were approaching the Rhine. Germany's industrial capacity was being systematically destroyed by strategic bombing. Whether Panthers cost 6 times more than M10s didn't matter anymore, because Germany could barely produce any vehicles at all. But the report mattered to Müller because it quantified a truth he'd understood intuitively for months. Germany hadn't lost because its equipment was inferior in many cases. It was superior. Germany lost because superiority wasn't enough when facing a 6-to-1 production disadvantage. The captured M10 remained at Kummersdorf through January. German engineers continued testing it, partly from professional thoroughness, partly because focusing on technical problems was easier than confronting the collapsing front. The vehicle became a curiosity, a reminder of American industrial methods that German engineers could admire but not replicate. On February 3rd, Soviet forces reached the Oder River, just 40 kilometers from Kummersdorf. The testing facility began evacuation procedures. Non-essential personnel were ordered west. Critical documents were packed for transport. The captured M10, along with various other test vehicles, was to be destroyed to prevent recapture. Schulze, who'd spent 2 months examining the American tank destroyer, requested permission to drive it one final time. Müller, who understood the sentiment, approved the request. On the evening of February 4th, as Soviet artillery rumbled in the distance, Schulze took the M10 through the testing yard's obstacle course one last time. The vehicle performed flawlessly. The twin diesels started immediately despite sub-freezing temperatures. The transmission shifted smoothly. The suspension handled the frozen ground without complaint. It was, even at the end, mechanically sound and operationally ready. Schulze parked the M10 in the center of the testing yard, shut down the engines, and climbed out through the open turret. A demolition team was standing by with explosives. They placed charges in the engine compartment, the turret, and the hull. At 2,100 hours, they detonated them. The explosions tore the vehicle apart, sending fragments of American-manufactured steel across the snow-covered ground. The destruction was thorough but somehow pointless. Thousands of M10s remained in service. Ford was still building them in Michigan. The loss of one captured vehicle meant nothing to the American war effort, while the loss of the Kummersdorf testing facility represented a significant blow to German research and development capacity. That asymmetry that one side could destroy equipment carelessly while the other hoarded it desperately encapsulated the fundamental imbalance of the war. Müller evacuated Kummersdorf on February 7th. He took his reports with him, though he doubted anyone would read them. The Wehrmacht was fighting for survival, now, not conducting technical analyses. Germany's remaining Panthers, Tigers, and other armoured vehicles would fight until they ran out of fuel, ammunition, or crew. The question of whether they should have built simpler, cheaper tanks 5 years earlier was academic. But the lesson remained, inscribed in the production figures, cost analyses, and engineering reports that documented Germany's encounter with American industrial warfare. Superior individual quality couldn't overcome systematic quantitative advantage. Sophisticated engineering couldn't defeat optimized mass production. Pride in technical excellence couldn't substitute for realistic assessment of material capability. The M10 Wolverine wasn't a better tank destroyer than the German vehicles it faced. It was a sufficient tank destroyer, built in overwhelming numbers, supported by logistics that German forces could only imagine. It represented a different philosophy of warfare, one that American industry had perfected and German industry couldn't match. By late 1944, the outcome was inevitable. The numbers had always been there for anyone willing to examine them honestly. Müller had examined them. He'd quantified the disparity: 6-to-1 cost ratios, 3-to-1 production rates, 5-to-1 labor efficiency. He'd documented how American pragmatism defeated German perfectionism through sheer volume of adequate capability. His report sat unread in evacuated files. The war continued without regard to its findings. Soviet forces overran Kummersdorf in April, finding scattered debris and abandoned equipment. Among the wreckage was twisted American steel from the destroyed M10, indistinguishable from the German vehicles that surrounded it. The Americans, meanwhile, continued building tank destroyers at Highland Park. The assembly lines didn't pause for analysis or reflection. They simply produced, hour after hour, day after day, vehicle after vehicle. By war's end, the M10 production run would reach 6,546 units. Each one cost approximately $50,000. Each one represented a fragment of American industrial capacity that Germany could observe, measure, and document, but never overcome. The broader implications of Kummersdorf's M10 analysis extended far beyond tank destroyers. The cost disparity, 6-1 for Panthers versus M10s, reflected a systematic difference in how the two industrial powers approached warfare itself. German military procurement had evolved from 19th-century traditions where quality craftsmanship defined military excellence. Prussian arms manufacturers had built reputations on precision, durability, and technical sophistication. The Mauser rifle, the Krupp artillery piece, the U-boat all represented German engineering at its finest. This tradition persisted into World War II, where Tiger tanks were assembled with watchmaker precision and Panther transmissions were machined to tolerances that would have satisfied aerospace engineers. American procurement came from a different tradition entirely. Henry Ford's assembly line, developed for the Model T, had revolutionized manufacturing by prioritizing speed and volume over individual craftsmanship. By 1940, American industry had spent 3 decades perfecting mass production techniques. When war came, those techniques scaled immediately to military production. The same methods that built cars, trucks, and tractors built tanks, aircraft, and ships. The M10 embodied this Ford-era philosophy completely. Its designers at the Fisher Tank Division hadn't tried to build the perfect tank destroyer. They'd designed a vehicle that could be manufactured efficiently using existing automotive industry infrastructure. The result looked crude to German engineers trained in precision machining, but it worked, and it could be built by the thousands. Müller understood this distinction intellectually, but emotionally, it remained difficult to accept. He'd spent his career in an army that valued individual excellence, that trained officers to think in terms of tactical sophistication and operational art. The idea that crude but numerous vehicles could defeat superior but scarce ones felt like a violation of military logic. Yet, the evidence was overwhelming. In Normandy, in the Falaise Pocket, in the Ardennes, German armour had achieved impressive kill ratios. Panthers regularly destroyed 3, 4, even 5 American tanks before being knocked out themselves. But the Americans kept coming. For every Panther that dominated a battlefield, 10 M10s and 20 Shermans were rolling off American assembly lines. The mathematics were brutal and inescapable. Germany produced its Panthers at extraordinary industrial cost, then watched them get destroyed at rates the production system couldn't replace. Each loss represented months of skilled labor, tons of scarce alloy steel, hundreds of precision-machined components. The Americans lost vehicles just as quickly, but their losses were replaceable within weeks. Their industrial system absorbed catastrophic battlefield casualties without faltering. Schulze had tried to explain this to his colleagues at Kummersdorf. The Americans aren't trying to build a vehicle that survives, he'd said. They're building a vehicle that's easy to replace. It's a completely different design philosophy. It seemed defeatist, a surrender to mediocrity. German professional pride demanded excellence. Building deliberately inferior equipment felt like betrayal of engineering principles. But Schulze wasn't advocating for inferior equipment. He was recognizing that inferior and sufficient weren't the same thing. The M10 was sufficient for its intended role. It could engage German armor at typical combat ranges. It could be transported, maintained, and operated by moderately trained crews. And critically, it could be manufactured in numbers that made individual losses tactically irrelevant. The Americans had solved a different problem than German engineers were trying to solve. German engineers asked, "How do we build the best tank?" American engineers asked, "How do we build enough adequate tanks to win the war?" The second question turned out to be more important. Historical records from the Ford Highland Park facility reveal the scale of American production efficiency. At peak output in mid-1944, the plant produced 14 M10 tank destroyers daily. Each vehicle moved through the assembly line in systematic stages, hull welding, drivetrain installation, turret mounting, weapons fitting, final testing. Total elapsed time from first weld to completed vehicle, 9 days. By contrast, the MAN factory in Nuremberg, one of Germany's primary Panther production facilities, completed approximately 15 Panthers weekly at peak efficiency, slightly more than 2 per day. But this peak was rarely achieved. Allied bombing, parts shortages, labor problems, and transportation difficulties meant actual production averaged closer to 1 vehicle per day. The Americans built 7 times as many tank destroyers with less industrial effort, and this disparity existed across every category of military equipment. American shipyards launched escort carriers faster than German U-boats could sink them. American aircraft factories produced bombers and fighters in numbers that overwhelmed German air defenses. American munitions plants generated artillery shells by the millions, while German forces rationed ammunition. Germany had entered the war, believing technological superiority would compensate for material disadvantage. The belief wasn't irrational in 1939. Germany's armoured forces had indeed achieved remarkable victories through superior tactics and equipment in Poland, France, and the early Soviet campaigns. But those victories required short, decisive operations before numerical advantages could materialize. By 1944, the strategic situation had reversed completely. The war had become precisely the attritional struggle Germany couldn't win. And the M10's $50,000 price tag quantified exactly why Germany couldn't win it. Müller's personal fate reflected the broader collapse of the German war effort. After evacuating Kummersdorf, he was assigned to a Scratch Kampfgruppe defending approaches to Berlin. He commanded the unit through February and March of 1945, fighting a series of delaying actions against Soviet forces that outnumbered his command by ratios that made the American material advantage seem modest by comparison. He survived the war, surrendered to British forces in early May, and spent 2 years in a prisoner of war camp. After repatriation, he worked as a technical consultant for German automotive companies, rebuilding in the post-war period. He never spoke publicly about his Kummersdorf report, though he kept personal notes that documented the analysis. In a letter written to a former colleague in 1953, Müller reflected on the M10 testing. "We measured everything except what mattered. We documented the armor thickness, the gun performance, the engine specifications. We calculated the costs with precision. But we failed to understand that wars are not won by superior vehicles, they are won by superior systems. The Americans didn't build better tanks. They built a better way of building tanks. That was the lesson we couldn't learn in time to matter." Schulze's post-war career followed a similar trajectory. He returned to Daimler-Benz, where he worked on civilian truck designs through the 1950s. He occasionally lectured at technical universities, where he used the M10 as a case study in design philosophy. "Optimization depends on your objective function," he would tell students. German engineers optimized for individual vehicle excellence. American engineers optimized for fleet capability. Both approaches produced excellent results within their frameworks. But only one framework matched the war's actual requirements. The captured M10 at Kummersdorf represented something larger than a single vehicle's specifications. It was evidence of a systemic mismatch between German military culture and modern industrial warfare. Germany had tried to fight a 20th century war with 19th century assumptions about what military excellence meant. Those assumptions weren't wrong in absolute terms. German vehicles were genuinely superior in many measurable ways. Panther armor protection exceeded M10 capabilities by substantial margins. Tiger firepower could dominate any battlefield where it appeared. German tactical doctrine and operational art were sophisticated and effective, but none of these advantages could overcome the fundamental arithmetic of industrial capacity. Germany allocated 55,000 man-hours to build each Panther. America allocated 9,000 man-hours to build each M10. Germany produced 350 Panthers monthly. America produced 850 M10s monthly, while simultaneously producing thousands of other vehicles. The 6-to-1 cost ratio meant Germany needed to achieve 6-to-1 combat effectiveness advantages just to break even. And while German vehicles might achieve 2-to-1 or 3-to-1 kill ratios in favorable conditions, 6-to-1 was impossible to sustain across an entire theater of operations. Military historians examining this period have noted the cognitive dissonance in German military thinking during late 1944. Reports like Müller's documented the material disparity clearly. Intelligence summaries detailed Allied production capacity accurately. Yet strategic decisions continued to prioritize quality over quantity, sophistication over simplicity, individual excellence over systemic efficiency. This wasn't stupidity or denial. It was the natural result of cultural assumptions so deeply embedded that contradictory evidence couldn't dislodge them. German military culture had centuries of tradition emphasizing technical superiority, tactical brilliance, and individual heroism. American military culture emphasized logistics, industrial capacity, and systematic efficiency. Both cultures were internally consistent, but only the American approach matched Total War's requirements. The M10 testing at Kummersdorf generated 47 pages of technical analysis, but the essential finding could be stated simply. America had solved the mass production problem for military equipment, while Germany remained trapped in craft production methods. This wasn't a temporary advantage America might lose or Germany might overcome. It was a structural difference rooted in decades of industrial development. By January 1945, when Müller submitted his report, the conclusion was academic. Germany's industrial capacity was collapsing under strategic bombing and resource exhaustion. Whether Panthers cost 6 times what M10s cost didn't matter when Germany couldn't produce Panthers at all. The Soviet advance was overrunning German industrial facilities. Allied armies were crossing the Rhine. The question wasn't whether Germany could optimize its production, it was whether Germany would survive the next 3 months. But the analysis remained relevant for what it revealed about how industrial powers approach warfare. The United States had recognized early that modern war required industrial mobilization on an unprecedented scale. American production planning began before Pearl Harbor, with Lend-Lease production establishing the infrastructure that would later support American rearmament. By the time America formally entered the war, its industrial machine was already gearing up. Germany, by contrast, didn't fully mobilize its economy for total war until 1943, 4 years into the conflict. Even then, mobilization emphasized increasing production of existing designs rather than fundamentally reconceiving what should be produced. The result was more Tigers, more Panthers, more sophisticated vehicles that Germany couldn't build in sufficient quantities to matter strategically. The irony was that German engineers understood mass production principles perfectly well. German factories had produced cars, trucks, and industrial equipment efficiently before the war. But military procurement remained captive to traditions that valued individual quality over production efficiency. The same culture that produced magnificent precision machinery couldn't adapt to produce adequate machinery in overwhelming quantities. The M10's $50,000 price tag was, in this context, revolutionary. It proved that adequate weapons could be built cheaply enough to field in decisive numbers. It demonstrated that combat effectiveness derived from systemic capability rather than individual quality. It showed that industrial efficiency was itself a form of military excellence. German engineers at Kummersdorf documented these lessons thoroughly. They measured, analyzed, and reported the disparity. But documentation didn't change the fundamental reality. By late 1944, Germany was fighting with the industrial base and military culture it had developed over the previous century. Transformation was impossible at that stage. The M10 itself continued in American service through war's end and beyond. The design eventually proved outdated as more powerful German tanks appeared, but the production system that created it remained relevant. When America needed more capable tank destroyers, it simply designed them and put them into production. The M36, with a 90mm gun, entered service in late 1944, using the same manufacturing infrastructure that had produced the M10. This adaptability, the ability to iterate designs quickly, and Implement changes across entire production runs was itself an advantage Germany couldn't match. German designs were often frozen for months or years because changing specifications meant retooling specialized machinery and retraining skilled workers. American designs evolved continuously because production systems were flexible enough to accommodate modifications. The final lesson of Kummersdorf's M10 analysis wasn't about tanks. It was about the nature of modern warfare itself. Industrial capacity had become the decisive factor in conflicts between major powers. Military excellence still mattered. Tactics, training, leadership, morale all influenced outcomes, but these factors operated within constraints set by industrial production. Germany could field the finest tanks, the best trained crews, the most sophisticated tactics. But if it could only field them in hundreds while facing enemies fielding thousands, the outcome was predetermined. Quality had become necessary but not sufficient. Quantity, when coupled with adequate quality, had become decisive. Müller had quantified this reality in his report. 6-to-1 cost disadvantage, 3-to-1 production rate disadvantage, 5-to-1 labor efficiency disadvantage. The mathematics condemned German strategy as clearly as any battlefield defeat. The captured M10 was destroyed at Kummersdorf in February 1945, but its significance persisted in the documents that survived, in the engineers who studied it, in the lessons that were eventually, slowly, painfully learned. Modern military procurement, with its emphasis on life cycle costs, production scalability, and logistical sustainability, reflects principles that the M10 embodied and that German engineers belatedly recognized. Wars are not won by superior weapons alone. They are won by superior systems that produce adequate weapons in decisive quantities, maintain them under field conditions, replace losses quickly, and adapt designs as requirements change. The M10 demonstrated these principles through its very ordinariness. It wasn't extraordinary. It was sufficient. And sufficiency, replicated across thousands of vehicles and millions of tons of equipment, proved more powerful than excellence limited by production constraints. That was the lesson quantified in the 6-to-1 cost ratio. That was the truth Müller documented in his unread report. That was the reality that American industrial capacity demonstrated across every theater of the war. Superior engineering couldn't defeat superior production. German perfectionism couldn't overcome American pragmatism. The war was decided not by which side built better weapons, but by which side built more adequate weapons, faster, cheaper, and in overwhelming abundance. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.